Unit 2, Data and Expressions Literals, Numeric Literals, String Literals, Control Characters, String Formatting, Implicit and Explicit Line Joining. Variables and Identifiers, Variable Assignment and Keyboard Input, Identifiers, Keywords and other predefined identifiers. Operators, Expressions, and Data Types. Operators, Arithmetic operators, Expressions, Operator precedence, Operator associatively, Data type, Multi-type expression. Computational problem solving, Restaurant tab calculation and age in seconds. 2.1 Literals 2.1.1 What is a literal? A literal is a sequence of one or more characters. 2.1.2 Numeric literals. A numeric literal is a literal containing only the digits 0 to 9, an optional sign character, 1 or 2, and a possible decimal point. The letter E is also used in exponential notation. If a numeric literal contains a decimal point, then it denotes a floating point value, or float. Example 10.24. Otherwise, it denotes an integer value. Example 10. Limits of range in floating point representation. There is no limit to the size of an integer that can be represented in Python. Floating point values, however, have both a limited range and a limited precision. Python uses a double precision standard format providing a range of 10 to 308 to 10,308 with 16 to 17 digits of precision. To denote such a range of values, floating points can be represented in scientific notation. 9.004560 plus E15, 9.004560 106, 8 digits of precision, 4.239 times 10 to the power of negative 16th. 4.239 x 10 to 16, 4 digits of precision. It is important to understand the limitations of floating point representation. For example, the multiplication of two values may result in arithmetic overflow, a condition that occurs when a calculated result is too large in magnitude, size, to be represented. 1.5 times 10 to the power of 200 asterisk 2.0 times 10 to the power of 210th INF, infinity, rather than the correct result 3.0 times 10 to the power of 410th. Similarly, the division of two numbers may result in arithmetic underflow, a condition that occurs when a calculated result is too small in magnitude to be represented. 1.0 times 10 to the power of 2300 / 1.0 times 10 to the power of 100 0.0, rather than the arithmetically correct result 1.0 times 10 to the power of -400. Since any floating point representation contains only a finite number of digits, what is stored for many floating point values is only an approximation of the true value. Built-in format function. The built-in format function can be used to produce a numeric string of a given floating point value rounded to a specific number of decimal places, 12/5/5/7.40.8571428571443 format, 12/5, 0.2f format, 5/7, 0.2f, 2.400.71. Finally, a comma in the format specify adds comma separators to the result. Format 13402.25, 0.2f, 13402.24. 2.1.3 String literals. In Python, string literals may be delimited, surrounded, by a matching pair of either single or double quotes. Print, "Welcome to Python." Welcome to Python. Additional examples of string literals are given in Figure 2-3. The representation of character values. There needs to be a way to encode, represent, characters within a computer. Although various encoding schemes have been developed, the Unicode encoding scheme is intended to be a universal encoding scheme utilizing between 8 and 32 bits for each character. Unicode is capable of defining more than 4 billion characters. The default encoding in Python uses UTF-8. An 8-bit encoding compatible with ASCII, an older, still widely used encoding scheme. UTF-8 encodes characters that have an ordering with sequential numerical values. For example, A is encoded as 01000001. 65, B is encoded as 01000010, 66, and so on. This is true for character digits as well. 0 is encoded as 00110000, 48, and 1 is encoded as 00110001, 49. Python has means for converting between a character and its encoding. The ordfunc gives the UTF-8, ASCII, encoding of a given char. For example, ord A is 65. The CHR function gives the character for a given encoding value, The CHR65 is a 2.1.4 Control characters. Control characters are special characters that are not displayed on the screen. Rather, they control the display of output, among other things. They are represented by a combination of characters called an escape sequence. The backslash serves as the escape character in Python. For example, the escape sequence \n represents the new line control character, used to begin a new screen line. 2.1.5 String formatting. The format function can be used to control how strings are displayed. Format value format _specify where value is the value to be displayed, and format _specify can contain formatting options. For example, format hello 20 #hello left justified in a field width of 20 char. Format hello 20 #hello right justified in a field width of 20 char. Format hello 20 #hello center justified in a field width of 20 char. Format 30 strings of 30 blank characters. Note: formatted strings are left justified by default. Print hello world. Format dot 30 have a nice day. Hello world. Have a nice day. 2.1.6 Implicit and explicit line joining. Matching quotes, except for triple quotes, covered later, must be on the same physical line. Matching parentheses, square brackets, and curly braces can be used to span a logical program line on more than one physical line. Program lines may be explicitly joined by use of the \\x. 2.1.7 Let's apply it. Hello World Unicode encoding 2.2 Variables and identifiers. A variable is a name that is associated with a value. The assignment operator, equals, is used to assign values to variables. An immutable value is a value that cannot be changed. Variables number and k are both associated with the same literal value 10 in memory. One way to see this is by use of built-in function id, number, id, k. 505494040505494040. The id function produces a unique number identifying a specific value, object, in memory. In this case, the variables refer to integer values, and integer values are immutable. An immutable value is a value that cannot be changed. Thus, both will continue to refer to the same value until one, or both, of them is reassigned, as depicted in Figure 2-10. Finally, in Python the same variable can be associated with values of different type during program execution, as indicated below. var equals 12 integer, var equals 12.45 float, var equals hello string 2.2.2 variable assignment and keyboard input name equals input. What is your first name? What is your first name? All input is returned by the input function as a string type. For the input of numeric values, the response must be converted to the appropriate type. Python provides built-in type conversion functions int and float. Line equals input. How many credits do you have? Number underscore credits equals int. Line equals input. What is your grade point average? GPA equals float. Line, or, number underscore credits equals int. Input. How many credits do you have? 2.2.3 What is an identifier? An identifier is a sequence of one or more characters used to provide a name for a given program element. Python is case-sensitive, thus, line is different from line. Identifiers may contain letters and digits, but cannot begin with a digit. The underscore character, underscore, is also allowed, but it should not be used as the first character. However, as identifiers beginning with an underscore have special meaning in Python. Spaces are not allowed as part of an identifier. 2.2.4 Keywords and other predefined identifiers in Python. A keyword is an identifier that has predefined meaning in a programming language. Therefore, keywords cannot be used as regular identifiers. Doing so will result in a syntax error. To display the keywords, type help in the Python shell, and then type keywords, type Q to quit. A simple way to check whether a given identifier is a keyword in Python is given below. Exit in dir underscore built-ins underscore true 2.2.5. Let's apply it. Restaurant tab calculation 2.3.1. What is an operator? An operator is a symbol that represents an operation that may be performed on one or more operands. Operators that take one operand are called unary operators. Operators that take two operands are called binary operators. 2.3.2 Arithmetic operators. Python provides the arithmetic operators plus, dash, asterisk, slash. Note that the symbol is used both as a unary operator, for negation, and a binary operator, for subtraction. 20 to 515, as binary operator, 10 asterisk 2 to 20, as unary operator, 2.4. Expressions and data types. An expression is a combination of symbols, or single symbol, that evaluates to a value. Expressions, most commonly, consist of a combination of operators and operands. 4 plus 3 asterisk k. A sub-expression is any expression that is part of a larger expression. Sub-expressions may be denoted by the use of parentheses. 2.4.2 Operator precedence. Operator precedence is the relative order that operators are applied in the evaluation of expressions, defined by a given operator precedence table. In fixed notation, operator appears between its two operands. There are other ways of representing expressions called prefix and postfix notation, in which operators are placed before and after their operands, respectively. Each programming language has its own rules for the order that operators are applied, called operator precedence, defined in an operator precedence table. Following Python's rules of operator precedence, the exponentiation operator is applied first, then the truncating division operator, and finally the addition operator. 4 plus 2 5 / 10 4 plus 32 / 10 4 plus 3 7. It is good programming practice to use parentheses even when not needed if it adds clarity and enhances readability. 2.4.3 Operator associativity. Operator associativity is the order that operators are applied when having the same level of precedence, specific to each operator. All operators except for exponentiation have left-to-right associativity. Exponentiation has right-to-left associativity. X 322 equals 81. 2.4.4 What is a data type? A data type is a set of values, and a set of operators that may be applied to those values. For example, the integer data type consists of the set of integers, and operators for addition, subtraction, multiplication, and division, among others. Integers, floats, and strings are part of a set of predefined data types in Python called the built-in types. Data types prevent the programmer from using values inappropriately to data typing in programming languages. In static typing, a variable is declared as a certain type before it is used, and can only be assigned values of that type. Python, however, Uses dynamic typing. In dynamic typing, the data type of a variable depends only on the type of value that the variable is currently holding. Thus, the same variable may be assigned values of different type during the execution of a program. 2.4.5 Mixed type expressions. A mixed type expression is an expression with operands of different type. Operands of mixed type expressions must be converted to a common type. Values can be converted in one of two ways: by implicit, automatic conversion, called coercion, or by explicit type conversion. Coercion versus type conversion. Coercion is the implicit, automatic conversion of operands to a common type, only if the operands can be safely converted, that is, if no loss of information will result. 2 plus 4.5 2.0 plus 4.5 6.5 Safe, automatic conversion of int to float. Type conversion is the explicit conversion of operands to a specific type. This can be applied even if loss of information results. Python provides built-in type conversion functions int and float. Float 2 plus 4.5 2.0 plus 4.5 6.5 2 plus int 4.5 2 plus 4 6. Note that numeric strings can also be converted to a numeric type. In fact, we have already been doing this when using int or float with the input function, number underscore credits equals int, input, how many credits do you have? 2.5 Age in seconds program. We look at the problem of calculating an individual's age in seconds. It is not feasible to determine a given person's age to the exact second. Analysis. This would require knowing, to the second, when they were born. It would also involve knowing the time zone they were born in, issues of daylight savings time, consideration of leap years, and so forth. Therefore, the problem is to determine an approximation of age in seconds with 99% accuracy. The program must work for dates of birth from January 1, 1900 to the present. Design. The program needs to represent two dates, the user's date of birth, and the current date. Hard-coded values will also be utilized for the number of seconds in a minute, number of minutes in an hour, number of hours in a day, and the number of days in a year. The Python standard library module datetime will be used to obtain the current date. 2.5.2 Restaurant tab calculation.